So, you've heard the headlines, right? About the absolutely massive amounts of electricity that new AI and data centers are going to need. The forecasts are, well, they're staggering. But what if the solution to this huge power crunch wasn't just about building more and more power plants? What if it was about rethinking the problem itself? A new paper from Duke University has this fascinating and kind of counterintuitive fix. Okay, let's get into it.
Right now, we are officially in a brand new era of electricity demand. For decades, demand in the US was pretty much flat, or it grew really, really slowly. But not anymore. Thanks to this explosion in AI, a big comeback in American manufacturing, and the electrification of pretty much everything, from our cars to our home heating, we're now facing a level of growth we just haven't seen in a generation.
And just how big is this growth? Well, get this. According to the North American Electric Reliability Corporation, the forecast for U.S. winter peak electricity demand is set to jump by a massive 21.5% over the next 10 years. That's a growth rate this country hasn't had to deal with since the 1980s. So this isn't some small ripple, it's a tidal wave of new demand heading straight for our grid. I mean, the Duke paper puts it very bluntly. They say that the challenge, it appears unprecedented. So why? Why is it so much harder now? Because unlike those growth spurts in the past, today we're facing way stricter permitting, there's less available land, and we have all these supply chain bottlenecks that just didn't exist back then. We're looking at historic growth, but we're trying to meet it with all these modern-day roadblocks.
And believe me, this gridlock is real. If you want to connect a new power plant or even a huge data center to the grid, you could be stuck in a line for 7 to 10 years. Need one of those big power transformers? That could take up to 5 years to show up. Just a few years ago, it was less than 1. You add in those super long permitting times and a major shortage of skilled workers, and you can see why the old solution of just building more is now incredibly, painfully slow.
Okay, so if building our way out of this is just too slow, what's the alternative? This is where the thinking gets really, really clever. The researchers are basically saying, what if the very nature of this new demand, the thing that's causing the problem in the first place, actually holds the key to the solution? Which brings us to this central, powerful question. What if these new, power-hungry data centers, instead of just being this massive burden on the grid, could actually become a flexible partner to the grid? Let's take a look at how that could even work. The hero concept here is load flexibility, and it's a really simple but powerful idea. It just means that a big electricity user, like a data center, has the ability to temporarily power down, just a little bit, when the grid is under the most stress. Like on the hottest afternoon of the summer, when absolutely everyone's air conditioning is blasting. So you can think about this new demand in two different ways. The old way is inflexible load. That means it runs at full power no matter what, which adds to the absolute peak demand and forces utilities to build expensive new power plants for electricity that might only be needed for a few hours a year. The new way is flexible load. This is the smart way. It intelligently avoids those peaks, which allows it to use the grid's existing capacity way more efficiently. And this is where it gets really exciting. Because by embracing flexibility, we're not just managing a problem. We are unlocking a massive resource that's been hiding in plain sight this whole time. The power we already have. Think about it like this. Our electric grid is basically a highway that was built for the worst possible rush hour traffic jam you can imagine. It has to be big enough to handle that absolute peak demand, but that peak might only happen for a few hours on the hottest or coldest days of the year. The rest of the time, a huge amount of that highway, all those extra lanes, they're just sitting there, empty. That headroom is an enormous, underutilized asset. So how much new demand can this headroom actually handle? The numbers from the study are just stunning. Even with just a tiny bit of flexibility, what the study calls low curtailment, the U.S. grid could absorb 76 gigawatts of new load. That's more than the entire forecasted demand from data centers. And what if these businesses can be a little more flexible? Well, that number jumps to nearly 100 and then over 120 gigawatts, all without having to build a single new power plant. Now, you're probably asking, what does low curtailment actually mean for a business? Well, to get that 76 gigawatts of new capacity, these new flexible customers would only need to scale back their power use for an average of 85 hours per year. There are 8,760 hours in a year, so that's less than 1% of the time. It is a tiny, tiny trade-off for a gigantic gain in grid capacity. And let's be super clear here. Curtailment does not mean a total blackout for the data center. Not even close. For almost 90% of those brief curtailment hours, the data center would still have at least half of its power on. So, in other words, this is about a partial, manageable power down. It's more like dimming the lights than flipping the off switch.
Okay, this all sounds great in theory, but what makes AI data centers the perfect partner to actually pull this off? Well, the answer is in the unique kind of work that they do.
The key is something the paper calls temporal flexibility. Think about it like this. When you do a Google search, you need that answer right now, instantly. But training a massive AI model, that can take weeks or even months. A lot of these huge computing jobs are not time-sensitive on a minute-to-minute basis. They are what's called deferrable, which means they can be paused and restarted without causing a major problem. And this represents a really fundamental shift. Legacy data centers, they had to handle all these real-time, unpredictable tasks. But these new AI facilities, they're totally different because they have a much bigger portion of these delay-tolerant workloads, like training an AI model. Their electricity demand becomes schedulable, it becomes predictable. And just like that, they transform from being a rigid problem into a flexible partner for the grid.
And here's the best part. This isn't just some clever trick to get data centers built faster. Embracing this kind of flexibility creates a smarter, cheaper, and more resilient grid that really does benefit everyone.
So what's the big payoff? Well, new businesses can connect to the grid way faster. We use our existing power system much more efficiently, which helps lower costs for all of us. And we avoid building those super expensive peaker plants that only fire up for a few hours a year. The end result is just a more resilient and efficient energy future for everybody.
Ultimately, just by shifting our perspective, we can turn one of our biggest energy challenges into a really powerful solution. It proves that sometimes the problem itself actually holds the key. And that leaves us with a pretty fascinating question to think about. If we can rethink the AI power crunch like this, what other complex challenges out there could be turned into solutions just by looking at them a little bit differently?